So in this video, I'd like you to calculate this definite integral, and then after you've tried it with pen and paper, if you could comment on the sign of your result. So have a go, come back after you've looked at it, and then a solution and comments will follow. So I will see you when you've had a look at it. Okay, welcome back. Let's look at the answer. So here is the integral that we want to calculate, and we see here that we have got log cubed of x squared, and I think before we start to calculate this integral, it's best to think about what these powers here mean. So log cubed of x squared means the logarithm of x squared all cubed. So whatever the value for the log is, it's multiplied by itself 3 times. So inside these big brackets, we can use the rules for logarithms and pull the 2 in front and rewrite log of x squared as 2 log x. But this 3 is playing a completely different role to that 2, so that just stays there. So we can now take this and put this back here in the integrand. So our integral is going to be the integral of 1 over x times this cubed. So the cube of 2 terms multiplied together is the cube of 2, which is 8. And that's going to multiply everything, so I've just taken it outside of the integral to make it look less concerning. So we have the 1 over x, the 8 outside, and the logarithm of x all cubed. And please don't think that this means the logarithm of x cubed. So we now look at this, and what I hope we spot to carry out the integral is that the derivative of log of x is 1 over x, so we have something cubed multiplied by the derivative of the something, and you could carry out a substitution, but I think this integral is simple enough to write it down by inspection. So let's try to do that. So our integral is going to be the integral of this, and the integral of the log cubed multiplied by its derivative is going to be something like the log of x to the power of 4. Now, to get the numbers right, and I've just left a space here to write it down, we differentiate and see what do we need to have here to obtain this. So if you differentiate this, you'll pull a 4 in front, and we don't have that 4, so we would have a factor of a quarter here, and then we would reduce the power by 1, so we would have log of x cubed, and that's exactly what we want. And then from the chain rule, we multiply by the derivative of what's in the brackets, and that's a 1 over x, so this is exactly right. If we differentiate this with the factor of a quarter, we obtain the integrand. So now 8 multiplies everything. I'll just keep big brackets. We evaluate this at x is 1. So we have a quarter times the log of 1 to the power of 4. But the logarithm of 1 is 0. So therefore this will vanish. And then we subtract and evaluate this at the lower limit. And that's a quarter times the logarithm of 1 over e. And 1 over e means e to the minus 1. So by the rules for logarithms, we can pull the minus 1 in front, and we have log of e, which is 1. Or you just say log of e to the minus 1 is minus 1. Doesn't matter how you want to do it. So this is minus 1, but it's going to be minus 1 raised to the 4th power when we look at the whole thing, and so therefore this is going to be plus 1. So now we see that the integral comes from the lower limit, and we have 8 times minus a quarter, and that's minus 2 written here, multiplied by plus 1. We don't need to write that, so the total answer for this definite integral is minus 2. So this was negative. Should we expect it to be negative? And the answer is yes, we do expect this. And the reason is that over our range of integration, 1 over x is going to be positive. We're integrating from a smaller value to a larger value of x, but these values of x are all less than or equal to 1. And that means that the logarithm of x and also the logarithm of x squared are going to be negative. And they are raised to a cubic power. And if you cube something negative, you obtain a negative result. So I'll just write down here that we expect a negative result as 1 over x is greater than 0, but log of x is less than 0, and if the logarithm of x is less than 0, its cube is also going to be less than 0. So therefore, the integrand is negative. Okay, so what we did on this slide to calculate the integral was we thought first of all about the powers, and that's one of the important things in this exercise that I've put in deliberately to help you distinguish x squared and the log cubed here. And then afterwards we just performed the integral by inspection and used our knowledge of the values of logarithms. On the next slide, I have an exercise for you to attempt with a hint should you need it. So in a similar way, I would like to suggest that you try to calculate this definite integral here. I've changed the limits slightly. If we had maintained this integrand with the limits of the previous exercise, it would diverge. And this is the result that you should obtain. And I'd like you to verify that you can obtain it and that you understand where the sign comes from. And I suggest you pause because in a moment I'll give you a hint and perhaps you can do it without the hint. Okay, welcome back. So here is the hint. In the integrand, we have 1 over x multiplied by 1 over log x. 1 over x is the derivative of log. 1 over log x is the log of x to the power of minus 1. Now in the previous exercise when we integrated this, we essentially added 1 to the power of log x. But log x to the minus 1, if you add 1 to it, you get log to the 0, which is a constant. And if you differentiate a constant, you are not going to get this. So instead, what you're going to get is essentially the logarithm of x. And then you put the limits in and work them out carefully, and you will get this answer. Why is it negative? It's negative because over this range, and we are integrating from a smaller value to a larger one, so we're integrating to the right. As we do this, we have the logarithm of x, but these values are less than 1, and therefore the logarithm of x is going to be negative. And if you actually think a little bit about what this integrand looks like, x, then what you will find is that over this range of integration from 1 over e squared to 1 over e, it is negative. This is actually a minimum, it then carries on upwards, but let's not worry about that. So the integral corresponds to minus this area that I've just hatched in for you. Okay, and with that I will stop this video.